Hi friends, happy morning. Today we are going to discuss previous year's questions asked from vector analysis. The last 15 lectures we seen theories regarding vector analysis and also we done some exemplar problems, right? Now we focusing on what are the different questions asked during the last 10 years in previous JAM examinations, right? Alright. So, let us directly go to the problems. So, here the first question is, for a vector A is equal to j plus k cap, B is equal to 2i cap plus 3j cap, minus 5k cap, C is equal to j minus k cap. The vector product A cross B cross C is. We seen what is vector triple product. Regarding the vector triple product, by considering these three vectors, which option is correct? Based on direction, different options are given. So, to know about this, we should calculate this vector product, right? So, let us copy this question to a plain board. So, what is A cross B cross C, right? So, let us think about what is A cross B cross C first, right? So, A cross B cross C expansion is, right, that is A dot C into B, right? A dot C into B minus A dot B into C. This is the right hand side of this expansion, right? Alright. Now, we can substitute these values here, right? See, A is equal to J plus, what is A dot C? J dot J1, K dot minus K dot minus 1. Then this part is 0, right? So, we need not calculate this. Now, A dot B, what is A dot B? A dot B is equal to, here no I cap component, here we have J dot J cap plus K cap only. So, this cross product will be 1 into 3, 3, right? And 1 into minus 5, that is minus 5, alright, into C, right? So, this is equal to 2C, alright. So, 2C means it has the same direction of C, magnitude only different. So, we can say in the direction of C, this is correct. In the direction opposite to C, no, here this is plus sign, it is the same direction of C, right? In the same direction of B, that is not true. In the direction opposite to B, that also not true. So, this option is correct, right? Now, let us go to another question. The second question is a unit vector perpendicular to the plane containing A is equal to I cap plus J cap minus 2K cap, B is equal to 2I minus J cap plus K cap, right? So, unit vector perpendicular to the plane containing two vectors A and B. What is that meaning? Any vector perpendicular to vectors, that vectors A and B lying on the same plane, then cross product, right? So, let us copy this question first. Now, see, suppose a plane containing two vectors A and B. Suppose this is our two vectors A and B. Suppose you have a plane. Suppose this is a plane, right? Suppose this is your A vector and this is your some B vector. Both are lying on the same plane. Okay. Now, another vector perpendicular to this is A cross B. We know, right? A cross B is perpendicular to both A and B. Alright. So what is the unit vector along this direction? N cap is equal to that particular vector across B divided by its modulus, right? So you should find A across B first, right? What is across B? A and B given, so A across B is equal to I cap, J cap, K cap, right? 1, 1, minus 2, 2, minus 1, 1, right? So I cap into, what is this? 1 minus 2, 1 minus 2, alright? Minus J cap into 1 plus 4, right? Plus K cap into minus 1 minus 2, minus 1 minus 2. So the vector is, across B vector is, that is minus I cap, right, minus 5J cap, right, minus 3K cap, right, minus 3K cap. Alright. Now the modulus of this is square root of minus 1 square, square root of minus 1 square plus minus 5 square plus minus 3 square, that is square root of 1 plus 25 plus 9, then that is root 35, right? So which is the option? Option D is correct, right? Minus I cap, minus 5J, minus 3K cap and a root 35, alright. So that also a simple question. Now let us go to another question. Another question is, the equation of a surface of revolution Z is equal to plus or minus root 3 by 2 x square plus 3 by 2 y square. The unit vector normal to the surface at the point A of root 2 by 3, 0, 1 is, right? So the surface revolution means that particular surface equation is given, right? We want a unit normal vector to this particular surface at this point we require, right? So let me copy again this problem, right? Now look here, what is the surface equation we seen? That is Z is equal to, right? So I can square this to remove the root, right? 3 by 2 x square plus 3 by 2 y square. Now I can write this as, so the surface equation is phi is equal to 3 by 2 x square plus 3 by 2 y square minus z square, right? So this is the surface equation corresponding to this expression, right? Now what is normal vector? If surface equation is given, what is the normal vector? We studied for any surface, suppose you take a surface, right? The normal vector is representing gradient phi. Gradient phi has the direction of normal to the surface. So what we have to take to find the unit vector along this gradient phi, you have to solve gradient phi divided by mod del phi. This is the unit vector. How you calculate gradient phi? Gradient phi is equal to I cap dou by dou x of this function, right? I cap dou by dou x of, then I cap into this one differentiation 3 by 2 into 2x plus j cap into dou by dou y of 3 by 2 y square, that is 3 by 2 into 2y minus, right, z square, that is k cap into dou by dou z of z square, right? Alright, this is the expression, alright. Now substitute these values. What is gradient phi? 2 cancel, 2 cancel. Now you can here dou by dou z of z square we can give us 2z, alright. So what is gradient phi is equal to 3x I cap plus 3y j cap minus 2z k cap. Alright, then at this point we require, then what we do? We give 3 root 2 by 3, right, I cap plus 3, what is y coordinate? 0, j cap, what is z coordinate? Minus 1, 2 into z is 1, that means 2k cap, right? Alright, so this is, and to find the modulus we have to divide, right? So first of all we can simplify this, then this is root 6 I cap minus 2k cap. So dividing by modulus, root 6 square is what? Right, root 6, here root 3, then root 6. So root 6 into 6 plus 4, that is root 10. Alright, so this you may write as 3 by root 5, right, root 3 by 5 I cap minus 2 by root 10 j cap, right? Correct, option B is correct, right? Remaining here plus, here also plus, here also plus, right? So this is the option B is the correct answer. Alright, now let us go to another problem. Next question is, a curve is given by r of t is equal to t I cap plus t square j cap plus t cube k cap. Alright, the unit vector of the tangent to the curve at t is equal to 1 is, right? So curve given in terms of the variable, that is r of t is equal to t I cap plus t square j cap plus t cube. The unit vector of the tangent to the curve, right? How we find what is unit vector of the tangent is dr by dt, differential, right? So what is dr by dt? So this we can directly calculate here. Dr by dt is, this is that particular normal vector, right? That is 1 I cap, t on differentiation 1 I cap plus 2t j cap plus this on t cube on differentiation 3t square k cap. Now t is equal to 1, this is equal to I cap plus 2 j cap plus 3 k cap, right? Now unit vector is dr by dt divided by mod dr by dt, that is I cap plus 2 j cap plus 3 k cap divided by square root of 1 square plus 2 square plus 3 square, that is root 9 plus 2 square, that is 4, that is 13 plus 1 root 14, right? So I cap plus 2 j cap plus 3 k, option D is correct, right? Remaining all different from it. Alright, so let us go to another question. Here the question is, see the line integral of the function u of xy is equal to 2y I cap plus x j cap, alright, along the straight line from 0 0 to 2 4 is, alright. So u of xy is given, so line integral what? This function u of xy u dot dr. So basically we can write this as u of xy 2y I cap plus x j cap. What is position vector? That is r is equal to, we studied as x I cap plus y j cap. In two dimensional, here I cap j cap only. So, 2-dimensional position vector is xi cap plus yj cap. Then what is dr? That is dxi cap plus dyj cap. Alright. So, that is integral 2y dx, alright, plus line integral x dy, right. Now, this is a mixed integral, both x and y variable coming. To remove that, to make it into one variable, they are given one information. Along the straight line from 0, 0 to 2, 4. Then what is this line equation? What? X minus x0, x1, that is 0, divided by y2, x2 minus x1, that is 2 minus 0, equal to y minus y1, that is 0, y2 minus y1, that is 4 minus 0. This is the equation of line, right? What is equation of a line? Two coordinate is given, x minus x1 divided by x2 minus x1 equal to y minus y1 divided by y2 minus y1. Alright. So, there I substituted, then what is this? That is 4x is equal to 2y, that is y is equal to 2x, right. Y is equal to 2x I am substituting here, then 2 into y is equal to what? 2x dx plus integral x, what is dy? Dy is equal to 2 dx, right, then 2 dx, then this is equal to 4x dx plus 2x dx, then 6x dx, that is equal to integral 6 into, right, 6x dx, right. The limit is varying from x coordinate is varying from 0 to 2, alright. Then integral 0 to 2. Then 6 into x dx on doing x square by 2. Limit is 0 to 2, alright. Then what is the answer? 6 into 2 square, that is 2. 2 square by 2, 2, then 12. 12 is the answer. So, you have to fill, this is a fill in the blank question. So, you have to write the correct value there, right. Alright. Now, let us go to another question. The line integral, alright. The line integral a to b f dot dl, where f is given x by root x square plus y square x cap, y by root x square plus y square y cap along the semicircular path as shown in the figure below is, alright. So, this point minus 1 0, this point is 1 0, and it is in the clockwise direction a semicircle is given, right. To calculate this, what we have to do? We want to find integral a to b f dot dl, alright. So, how we find instead of calculating? So, you can directly do like this, integral a to b, right, x by then x divided by root x square plus y square x cap plus y divided by root x square plus y square y cap, alright, into this position length element, right, length element in 2-dimensional, that is dl is equal to dxi cap plus dyj cap, right. So, dxi cap plus dyj cap, alright. Now, it is better to calculate this by Cartesian system. If you differentiate this and all, we will take it will long time, right. So, best is you give the substitution, because in a circular path, how we represent, this is a plane polar, right. It is a plane, right. In a plane polar coordinate system, suppose you want to find a point y, right? Suppose a point P want to express, then what is x coordinate? If this angle is theta, this is r cos theta, and corresponding y is r sin theta. We studied how to represent x and y in plane polar coordinate system. That is x is equal to r cos theta, y is equal to r sin theta. If I substitute here integral a to b, right, then the limit is varying from pi to 0, right, pi to 0, right, here pi, here 0, alright, half circle, right, then pi to 0, alright, x is equal to r cos theta, then this is r cos theta whole square, r sin theta whole square, sin square theta plus cos square theta 1, and r again come out, right, and here dx x cap I am giving, dy y cap I am giving, right, because here already we chosen unit vector as x cap y cap, right. So this dx x cap dot x cap, that is dx. Dx is equal to how? X is equal to r cos theta, y is equal to r sin theta. Then what is dx? Dx is equal to minus r sin theta, dy is equal to r cos theta, right. So here I am substituting that dx is equal to, this dx is equal to minus r sin theta, right, sin theta, right, plus limit is same. So again here I am writing plus y is equal to r sin theta, right, dy is equal to r cos theta, r cos theta divided by root of x square plus y square, right, square x square plus y square r square, right, cos square theta plus sin square theta is 1, then root is r, again r, right, then right, dx is equal to r minus r sin theta d theta, dy is equal to, because dx by d theta I am finding, that only minus r sin theta, then d theta I am taking here, this is d theta. So here one d theta we have, here also one d theta we have, d theta we taken out, alright. Now this is very simple, pi to 0, look here, r is common, this part is negative, this part is positive, but value is same. So here 0 d theta, then answer is 0, alright. Then option B is correct, alright, alright. Now let us come to another problem. See, if f is a constant vector and r is the position vector, then gradient of f dot r would be, right. So what is a constant vector? See, f is equal to all coefficient of I cap j cap will be f0, f0 I cap plus f0 j cap plus f0 k cap. This is a constant vector, right. F is a constant vector. Then gradient of f dot r, what is r? R is the position vector. R is what? X I cap plus y j cap plus z k cap, alright. Now what is f dot r? First I can find out f dot r. What is f dot r? That is f0x, f is equal to f0x plus f0y plus f0z, right. Now gradient of this, what is gradient? I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z, and about this function f0x plus f0y plus f0z, alright, alright. Now so f0x, now substitute here, what is this? Dou by dou x of x is 1, so f0 I cap. Now dou by dou y of f0 y, f0 j cap only remaining. Right, here dou by dou z of z1, then f0 k cap. This is what? This is our starting f, right? So this is equal to f. So when we solved this, what we got? F. So answer is f. Alright? Alright. Now we have another question here, right? If the surface integral of the field a of x y z, that is 2 alpha x beta y j cap 3 gamma z over the closed surface of an arbitrary unit sphere is to be 0, then the relationship between alpha, beta, gamma is, right. So if surface integral, what is surface integral? See what I am expressing. Surface integral is equal to, how I can represent, a dot, that means 2 alpha x I cap plus beta y j cap minus 3 gamma z k cap. This is our a dot dA or ds. This is to be 0, right? But by Gauss's divergence theorem, what you know, if surface integral I can represent as how the del cross of this, right? Suppose this function is a given, then divergence of a dot dv equal to 0, right? So this 0 means surface integral is equal to 0. What is Gauss's divergence theorem says? Integral a dot ds, right? Surface integral is equal to div a, then this surface changes to volume element. Surface element changes to volume element. So if this is valid, this is 0 is given, then del dot of a, divergence of a dot dv also 0. Then the relationship between alpha, beta and gamma, the volume element never be 0. So this part is 0 only if this divergence a is 0. Then divergence a we can equate to 0. What is divergence of a? Right. Equal to 0 means, what is 0? Divergence of this, right? What is divergence? I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z dot. What is a? A already we have here 2 alpha x I cap, right, plus beta y j cap minus 3 gamma z k cap. All right. Now divergence says 0 means this, that is 2x, that is 2, right, 2x 2 alpha x, 2 alpha x, okay, that means 2 alpha x on doing 1 plus here y on doing 1, then beta, here minus 3 gamma z on doing with respect to z, this will be 1, then I can write minus 3 gamma, alright, equal to 0. Now to make in the required format, divide whole divided by 6 either side, then what come? 2 by 6, then alpha by 3, right, plus beta by 6 minus gamma by 2 equal to 0. Which is the option? Option B is correct, right? Alright. Correct. Option B is correct. Alright. Now let us go to another question. Right. So here one question is given, the flux of the function f y square x cap plus 3xy z square y cap plus 4y z z cap passing through the surface of ABCD along n cap is. So here one cube is situated at the origin is given. What we want to find? ABCD, the one face is given. So along this, what is that? Because of this field, I am applying this field through this cube. Then through this particular area ABCD, what is that field coming out? That is the flux, right? So to find the field, it is very simple. How we find a, see, this direction is, this particular diagram, this direction is y cap. This direction is y cap. Alright. Then the field, this component only pass through this direction. Right. Now what is flux? Flux is equal to integral f dot dA. Right. We studied already electric flux, what we give. Integral E dot dA in electrodynamics we have done. Why we doing like that? That is that field passing through that particular area, normal to that surface, right? So here what is the field? Flux is equal to integral this particular y cap direction field only I required, because through this phase, this is the normal component, right? What is field? What is flux? Field line passing through a particular area in a direction perpendicular, right? So I must require this component of this field, right? That is 3xy minus z square, alright. What is area element y cap? This area element is very important, right? Because this area, this length is along z, then dz. This length is along x, then dx, then dx dz. Direction of area y cap, then dx dz y cap. Alright. Now dot product y cap dot y cap 1. Then flux is equal to, first you integrate with respect to x. Now note that y is equal to 1. This y you can give us 1. Why? Because this particular area situated at y axis at y is equal to 1. So integral 3x minus z square dx dz. First you integrate with respect to dx, then what you get? And give, this is a surface integral. Cube side is all varying from 0 to 1. So double integral 0 to 1, 0 to 1. Because x and z is the variable. Dx dz. Right? What is the maximum value of z? 1. What is the maximum value of x? 1. Alright. Then now give with respect to x I am integrating. Then 3x square by 2 minus z square. Right, z square x 0 to 1 dz. That is phi is equal to integral 0 to 1, putting x value 1, then 3 by 2 minus z square dz. Right, again integrating 0 to 1, right, 3 by 2, but increment is z. 3 by 2 is z minus z cube divided by 3, that is 0 to 1. Then 3 by 2 minus 1 by 3, that is 9 minus 2 divided by 6, that is 7 by 6, that is approximately 1.12. Right. So this is the 2 decimal places they are asking. So decimal place 2 only you write after getting the answer, right? Alright. Now let us go to another question. Here, see, consider a vector field F is equal to y I cap plus x z cube j cap minus zy k cap. Let C be the circle x square plus y square plus equal to 4 on the plane z is equal to oriented counterclockwise. The value of the contour integral, right? So in this question they are asking the line integral and function is given. So as per the Stokes theorem, how you convert line integral into surface integral, right? So instead of calculating this f dot dr, right, you can calculate a surface integral del cross f dot dA, right? Now what is del cross f? You find del cross f first. Okay, what is del cross f? Del cross f is equal to I cap j cap k cap, and here dou by dou x, dou by dou y, dou by dou z, here y, here x z cube, here minus zy, right? That is equal to I cap into dou by dou y, that is minus z, right? And minus dou by dou z of x z cube, that is minus 3x z square, minus j cap into, right, with respect to this z, with respect to x z y 0, this also 0, plus k cap into, right, dou by dou x of this is z cube, all right. Now with respect to y, this is minus 1, all right. So this is the value we got, right. Now look here, now come to the actual meaning. The value of the contour integral, where let C be the circle x square plus y square is equal to 4 on the, then x square plus y square equal to 4. That is a circle on xy plane, but it is located at z is equal to 2. How I represent? See, this is xy plane. Say this is xy plane. Suppose this is z axis. Any direction you can take. Okay. Now xy plane circle means that circle is located here parallel to xy axis, but it is touching at z is equal to 2. Z is equal to 2, right? Then what is that area direction? Area direction is z cap. That is very important, right? Z cap. Area direction is z cap or k cap. Here k cap is given, right? K cap, all right. Now in k cap direction, that field only going through this surface, right, perpendicular to that surface. Then out of the given function, this del cross f dA, right, what is dA? I am writing this. See, look here, integral, this part I am calculating, del cross f value we already got, but k cap component only we take. Why? Because this field is passing through a circle that is in the xy plane. Then the area component, area direction is k cap direction, then field component in the direction of k cap only, passing perpendicular to that particular area. All right, all right. So what is that function? Here field is this one, right, z cube minus 1 into k cap, right, z minus 1 into k cap. Now we can calculate, right? So let me write here surface integral. What is field? Z cube minus 1 k cap, right. So I am calculating this part instead of calculating this dot. Now what is the circle area? That is pi r square. What is r? X square plus y square is equal to r square. Then r is equal to 2. Here r square is given as 4, then r is equal to 2. That is the standard circle equation. Alright. Then if I put r is equal to 2, area is pi r square. That is pi into 2 square. Right. What is that area direction? K cap. Right. So K cap. Right. Now you can K dot K cap. That is K dot K cap. That is 1. Right. And Z, the circle is located at Z is equal to 2. Then 2 cube is Z is equal to, I am giving 2 cube. Z is equal to 2. That means 7 into pi into 2 square. Right, after integration. Alright. So what is this K cap dot K cap? That is 1. That is 1. Right. Then this value is, alright, 7 into 2 square. That is 4 into 7, 28. 28 pi. Alright. 28 pi is the answer. Alright. So which is the option? Option A is correct, right? Alright. Now let us go to another question. See here, a hemispherical shell, right? A hemispherical shell is placed on the xy plane centered at the origin for a vector field is equal to minus y ex cap. See, this ex cap notation is actually I cap. Some book using instead of I cap x cap or instead of I cap ex cap. Okay, don't confuse with it. So I am writing E as, for convenient I am writing this as minus y divided by, splitting this denominator, y square. This is, we can write this as x cap. I can write as, this is x cap, right? Here x y cap divided by x square plus y square. Okay. Now we want to calculate del cross E dot dA, right? So it is better to use in a surface, right? We can represent it using polar coordinate system, because this is x cap y cap, xy plane the function is given. So if I give y is equal to, again you can use, right, y is equal to, you use as, right, because in here dA, I am writing dA as, what is dA? Right, in the xy plane, what is area? That is dx dy, right, z cap, right, alright. Now I can convert, right, x cap y cap. Now this y is equal to, suppose I am giving r sin theta, right, alright. So this is a del cross E dot dA, right. So integral del cross E dot dA using Stokes theorem, you can write as integral E dot dl, surface integral converted into line integral. That is very easy, right. So I can write this as dx x cap plus dy y cap, length element, alright, length element I am applying, alright. Now put x is equal to r cos theta, see, x is equal to r cos theta, y is equal to r sin theta, dy is equal to r cos theta and r cos theta d theta and dx is equal to r into cos theta changing minus sin theta d theta, right. Now substitute here, integral minus what is y, r cos theta. What is x square plus y square? That is r square. R square into cos square theta plus sin square theta. So I can write it r square. Now what is dy? Right, this one here dx come, y dx, x cap dot x cap 1, here dx come. So dx value minus r sin theta d theta, minus r sin theta d theta, alright, plus again x is equal to what? R cos theta. R cos theta, x square plus y square, again r square, right. Now this dy is r cos theta, right. Dy is equal to r cos theta d theta, alright. So because here x dy come, x dy come, y cap dot to y cap 1. So minus dy is r cos theta d theta, right. R x is equal to r cos theta and y dy is equal to x is equal to r cos theta. Then here dy is the component. Here I applied dx, alright. Here I applied y I changed, right. Y is equal to, I am sorry, y is equal to r sin theta. Y is equal to r sin theta. Already we have a negative sign here, right. Don't confuse. R cos theta, then dy is r cos theta d theta, right. R cos theta d theta, alright. Now hemispherical surface, look here, over a hemispherical surface, see, suppose for a hemisphere you consider, right, here 0, here only pi come, right. So integral 0 to pi is the limit, alright, alright. Now this I can write as integral 0 to pi, see here r square, then sin square theta plus cos square theta only remaining, right, d theta, right. Now sin square theta plus cos square theta is 1, right. So d theta on integration theta, theta 0 to pi, what is the answer? Pi. Pi is 3.14. So 3.14, alright. So this about this question. Now let us go to another question, that is the final question. Look here. Let f of xy equal to x cube minus 2y cube, right. The curve along del square f is equal to 0 is, what is del square f? This is xy, that is the two-dimensional Laplacian operator, right. This is Laplacian equation. So what is del square f? That is dou square by dou x square plus dou square by dou y square. This is our Laplacian operator of f. What is f? X cube minus 2y cube, right. Then this is on double differentiation, 3x square first differentiation get, or I can write dou by dou x of first differentiation 3x square my plus dou by dou y of first differentiation what come, sorry, minus, here minus come because of this minus sign, right. Or we can put a minus 6, right, y square. Now we again differentiating, this is 6x minus this is 12y. This is equal to 0 given, that is equal to 0. Then 12y equal to 6x, right, or you can write x is equal to 2y. X is equal to 2y. Then option B is correct, right? So this is all about this section. In the coming